We go. All right, so we're going to have a quick look at OpenSCAD, which is the CAD graphics program that I prefer for building the motor with. And what this is all the STL files displayed. So if we look at the, for example, the rotor STL file, and you can see that it's just a disk with holes in it. All right, that's why I like this. This is the wrong one. Doesn't matter. This is the one I'm using because you see I put a groove around the edge, and I kind of that's because I want to put a carbon fiber around it. But we'll see what I do anyway. The point being, this, you see, it's a programming language, more of a programming language here. And I'll show you number one. You go to help and cheat sheet. Now this isn't a tutorial. This is just showing you what I use and why I use it. And you can see this cheat sheet is really nice. And what we're going to look at here real quick is, all right, I'm using the cylinder. See, this is 2D. That's another story altogether. 3D cylinder. And so we can look at the examples here it has for cylinder and how to do the cylinder. Okay, the first thing, let's see. This one here is generally what I use because you see it just says, let's go over here. Let's open a new one. And I've got this one called test, nothing in it. Okay, and what we're going to do, we're going to say cylinder. See how it comes up there? So nice. And it gives us the examples, height, radius, and radius. So we're going to go with the height of 10. Actually, we're going to go with the height of 5 and radius of 10. Bottom radius and top radius, I think. And so save it, and there you can see it. Okay, so you see the top. You can see that is increments of 10. And you see it's got a radius of 10. So from the center to the outer edge, the radius is 10. Now let's see which is top and which is bottom. Yeah, there you go. That's the top. The first one is the bottom and the second one is the top. So you want it symmetrical, and I'm just doing save. Okay, now another thing, you see how you can see all the segments around it. So the command for that, let's go back to our cheat sheet. I said our cheat sheet. And you can see down here, special variables, you have number of segments, $FN. Okay, so I'm going to hit $FN equals, and I like 200, and save it. And you see how smooth it went because it's 200 segments. So anyway, so that shows the cylinder there. And what's cool, okay, let's make this bigger. Let's make it 100 by 100. Oops. Whoa. Okay, get down here where we can see it. Okay, we're going to put another cylinder in here. Oops. And let's make this one 10 height and 10 width. Let's make it 20. Make it bigger. 20. And Control S, and there it pops up in the middle. one more thing, because we have whether it's centered is true or false. Okay, let's say true for center. Control S, and you see it pops down. Here's another thing real quick, is when you put a exclamation point in front, it shows only the command there. So, okay, what I was going to show you is center. See, it's centered there. If we change it to false, so it pops up there. So apparently default is false, but I always put it in. If I knew how to spell. Okay. Always put it in just so I know what's going on. All right, so the other thing I like to use is difference. Difference is a method, so it needs the bracket, and a closing curly brace. And okay, now then it depends on the order. You see it cut the wrong one here. What I want to do is put a hole in that other one. Okay, so I made a hole in it, but you can see it's not all the way through. So what I need to do is make this one, well, if I just change the center to true, okay, put it down too low. I can make it bigger, and it cuts all the way through. Or another way to do it, which I tend to use a lot, translate. And you see this one has a open parentheses and a square bracket and X, Y, and Z, and close the square bracket and parentheses, and okay, I don't have it doing anything. I'm going to make this on the Z axis. I'm going to move it down a 1. See, and there we go, and it punches it. And you could see that if I put that exclamation point here, you can see that it's down 1. Okay? Now then, see, so we have a hole in it. Let's look at this. Look what I do with the magnets here. This is interesting. Okay, let's just make this down here. Actually, something else I wanted to show you. It uses the C for comments. Okay, so we can comment a whole section using the / and the asterisk. What did I do? I didn't copy it. Okay, there we go. And here's our magnets. You see our little magnets. What it has here, it has the 4 increments of 15. I mean, it begins at 15. And for each 30, it goes 360. But what I'm using it as in my rotate here, okay? Instead of using it in the rotate, I'll show you. That's what makes it go around. Okay, first I want to show you if we put this as a 0, see, we shift it back. I wanted it to start up there. So you see the difference? I shifted it by 15 degrees. Okay, but let's do this. Instead of rotating it, let's move it along the y-axis. Okay, all right, like I said, I can comment this out. See, there we go. Now we're going along down the y-axis. How do I have that? Yeah, that's what I thought. I had it upside down. You see, so they're just for each increment of 15. See, and I can move this back to 0. And you see the whole thing's just down here to 0. So I just wanted to show you that. There's a lot of things you can do, and it's easier for me anyway. I mean, if I was doing stuff for hobby, I would use Tinkercad because it's easy enough. You can see this is a stand I built for a my mouse button isn't happy. I need a new mouse. This is a stand I made for a ESP32-C3 to fit in there, and a little 1306 monitor. So that's that. I prefer OpenSCAD. I think the most recent date on it is 2021. And I'm real happy with it, what I get out of it. So that's all. Like I said, this isn't a tutorial. This is just showing you things. You can even put variables in here and make things rotate and animate stuff. So I could probably get real fancy and make this do exploded and imploded, you know, go back and forth and stuff. So anyway, I'm not that enthusiastic. I just like making this stuff, because then once you get your design right, you just hit the render button and it renders it, and you save it as an STL, export it as STL, and then there you go. You're ready to slice it. And so that's all I wanted to talk about, was why I prefer OpenSCAD.